the shop. This is the second episode on the Tripan tool post holders. In the first episode we made the long profiles with the dovetail, and I already sliced them up into individual holders, and I bandsawed them with about 1.5 millimeters of stock allowance, and now we're going to finish them on the shaper to be square and look nice. So let's go to the shaper and make some chips. We're here at the shaper, and I have one of my rough sawn blanks. These two surfaces are bandsawn, and I will square off each of them on the first side. And I do this by dropping them into the vise at a slight angle backwards. Then I take my small machinist square, I drop it into the vise and butt it up against the part. It will touch down there first, and I can use my copper drift to tilt the part against the square. And when you don't see light between the part and your square, that means that you're square, and then you can take your facing cut, clamp it down, retract the tool so that we don't crash into stuff, touch off, and I will touch off on both sides because the bandsawn surface is not flat. Yeah, this is a bit higher, so let's go out of the workpiece, go down 0.6 millimeters, hand crank it, be sure. Get some cutting oil on there and go for it. Okay, this is what we're going to do to all 10 of the tool holder blanks, and while the shaper was working on this piece you saw me over at the chamfering machine, breaking all the edges of the tool holder blank I faced previous to this, so I can have this machine running and do something else in the shop. That's also the reason why I want a power feed, or I built a power feed for my milling machine, so I can do a long facing cut and I can do something else in the meantime, because watching the cutter for 10 minutes is, yeah, not the best use of time. Now we're cleaning up the second side on all the tool holder blanks, and in that case my part can rest on a parallel, because we have already machined the first side square to the rest of the piece. Okay, right now we're in the process of roughing out the slot for the tool bit, and of course we do this on a milling machine because we have power feed there now that we can use for this task. And let's go over to the milling machine and I show you the process. Okay. We're over at the milling machine and I have already a parallel in the vise and everything is clean, and we drop our part in the vise, clamp it down lightly, knock it in place and clamp it. Cutting the slot, we start in the center. We're plunging down 3.8 millimeter each step until we reach 11.5 millimeters, and then we're going to offset the cut until we have the desired width. Of course with allowance for finishing, because this is a 6 millimeter 4 fluid high-speed steel roughing end mill. Now let's bring the spindle down. Lock it in place. I know most people use the quill on these machines for setting the height of the cutter. I do that too, but only with light cuts. With heavy cuts, roughing cuts, I prefer to have the quill up in the housing, fully supported and clamped. Not taking any chances there, and as I have a gas scale on the Z axis, I can go down quite precisely. So everything is locked. We're running it at 580 RPM and a feed of about maybe 50 millimeters per minute. Okay, first pass. Now we can go down another 3.6 millimeters. And return. Okay, that's the last of the tool holder blanks roughed out. Next step will be to finish the slot, do the finishing cut with a regular end mill, not with a roughing end mill, to clean up the sides and the bottom. Right now I'm in the process of finishing the slot for the tool bit, and for that I'm using a 6 flute 6mm carbide end mill, a finishing end mill, high helix. That, by the way, leaves a beautiful finish here on the side wall, and also the bottom finish is not too shabby. And to finish the slot, I clamp the piece in the vise, knock it down on the parallel, and tighten the vise final. Then I'm running the end mill through the center of the slot to finish the bottom in the center. Then I'm going to do a finish pass on both sides in conventional milling, and then I'm going back with a climb cut spring pass to get any flex out of the tool. And now the spring pass. And that's how simple the finishing is. These 6 flute finishing end mills with the high helix, I think that's a 45-degree one, leave a super nice finish. Only problem are the chips. These are nasty. When you get these stuck in your finger, that hurts. Okay, we're right now in the process of drilling the clamping screws for the tool bit. I'm drilling them 5mm so I can tap them with an M6 tap. Spiral flute machine tap, of course, directly on the milling machine. I'm using a stop drill clamped short in a collet and due to that I can drill without centering. These drill bits don't tend to wander, and also I regrounded freshly on the tool and cutter grinder, made a nice 4-facet grind, and that's like a split point. And as you saw, the chips come out very nicely, and the holes are very much on size. For chamfering, I go over to a drill press and do it there, so I don't have to change tools on this machine. I have a 60-degree counterbore over here in the drill press, and I set my depth stop so I get always a nice evenly sized counterbore. And back on the milling machine, we are power tapping the clamping holes. The new milling machine has a quite nice feature for tapping. It has an automatic mode where it switches the spindle automatically on when you leave the upper position, and it switches the spindle to reverse as soon as you reach a lower limit switch that you can adjust by the depth stop. And when you reach the highest position again, it turns the spindle off completely, like this. Or let me show it without a workpiece. It turns, you go down, you're tapping, you're tapping, you're tapping. You reach the lower limit switch, it reverses, you go back, you go back, you go back. And when you hit the upper end, it turns off the spindle. That's quite a nice feature for small production runs like this. Yes, 10 pieces is a production run in my mind, and normally I can't stand production work, but having 10 additional tool holders for the lathe will be great, because I will not have to change tool bits in the tool holders as much. This goes. The tool holders call for a big countersink here. No, not countersink, counterbore. 50mm in diameter and 6mm deep. And I don't have a 15mm end mill. Probably no shop in Germany has a 15mm end mill. 14 and 16 are common, and I didn't want to bore it out with a boring head or mill it on the rotary table. So what I decided to do is I made my own counterboring tool with a piloted pin. Let's go to a milling machine and I show you the tool. Here you can see the tool. The body is a piece of 5mm hardened steel. It's a cutoff from a 5mm punch. And I made a cutter that clamps onto this 5mm bar. This is a piece of 60mm drill rod. I turned it down to 50mm in diameter. I milled a flat in front here to half the diameter to create the cutting edge. Then I filed the relief behind the cutting edge. As you can see, this is going up and this is clearance for the cutting action. And then I hardened it, made it cherry red, dropped it in water, cleaned up some surfaces and annealed it to a light straw yellow. Then I honed the cutting edge, and yeah, that's it. That's my counterboring tool. And with the pilot, the pin sticks out in front of the cutting edge. With the pilot, this is a very stable and very rigid setup for counterboring. And I will show you one of the parts while being bored. Okay, I brought you behind the milling machine, and now you see from the back of the vise against the tool and the workpiece. And now we're going to counterbore this 6mm deep. Some cutting oil. You have to run it pretty slow because the drill rod will not take heat on the cutting edge. It will soften right away when it's getting hot. So I'm running it at 180 RPM with plenty of cutting oil, and I'm feeding with the fine feed of the quill because it needs kinda much cutting pressure. Okay, that's it. That's the counterbore with a pretty simple tool, and yeah, that's 7 down, 3 to go. I will do those off camera. Okay, I did all the counterboring and all the 10 tool holders, and I wanted to show you the tool again. And as you can see, this is a very simple piece. This is the shafting, the piece of 5mm punch, and this is just drill rod hardened and honed to a cutting edge. And before honing, of course, I drilled the hole for the set screw that holds it on the shaft. Let's see. And this, oh yeah, this tightened itself. The set screw is locked in place. I'm not going to open it because the torque while counterboring just sheared. No, not sheared. These screws almost seized up because there is I ground a flat spot on this hardened shaft, and the screw is of course against the flat spot, and by torquing it, it's in there. It's not going to be loose. I might have drilled the screw out when I have to take this off, but what I wanted to show you is the relief here, and this is just filed by eyeball to approximately 2 or 3 degrees of back rake. The cutting edge is square, or the chip surface is square. It's just machined down to half the diameter of the counterbore tool. Then hardened and honed to an edge. And after I did the 10 tool holders, it's still cutting and working pretty good. And I have one of the tool holders here, and this is how the pilot pin engaged the pre-drilled hole, and then to bored out the hole. Without the pilot, this would be a very wonky setup. It would, you know, weeble wobble around. But with the pilot, even with this thin 5mm shank, it was no problem at all. And yeah, that's it. That's the counterboring. Okay, I think the tool holder blanks are almost done, and this part of this series is already long enough. So, hope you enjoyed this. Thank you for watching and see you next time.